Welcome to the Vector Academy. School of Computing. Competitive versus uncompetitive. What kind of a programmer are you? The core directive in competitive programming is: given well-known computer science problems, solve them as quickly as possible. The term well-known computer science problems implies that in competitive programming, we are dealing with solved computer science problems and not research problems, where the solutions are still unknown. To solve them implies that we must produce working code giving the same output as the problem author using the problem author's secret test data within the stipulated time limit. The need to solve the problem, as quickly as possible, is where the competitive element lies. Speed is a very natural goal in human behavior. Problem description. Let x, y, be the coordinates of a student's house on a 2D plane. There are 2n students and we want to pair them into n groups. Let di be the distance between the houses of 2 students in group I. Form n groups such that cost equals summation di from I equals 1 to n such that di is minimized. Output the minimum cost. Constraints. 1 is less than or equal to n is less than or equal to 8. 0 is less than or equal to x, y is less than or equal to 1000. Sample input. N equals 2. Coordinates of the 2n equals 4 houses are 1, 1, 8, 6, 6, 8, and 1, 3. Sample output. Cost equals 4.83. Can you solve this problem? If so, how many minutes would you likely require to complete the working code? Now ask yourself, which of the following best describes you? Uncompetitive programmer A, the blurry one. Step 1. Reads the problem and becomes confused. This problem is new for him. Step 2. Try to code something. Reading the non-trivial input and output. Step 3. Realizes that all his attempts are not accepted. Greedy. Repeatedly pairing the 2 remaining students with the shortest separating distances gives the wrong answer. Naive complete search. Using recursive backtracking and trying all possible pairings yields time limit exceeded, TLE. Uncompetitive programmer B, give up. Step 1. Reads the problem and realizes that he has seen this problem before. But also remembers that he has not learned how to solve this kind of problem. He is not aware of the dynamic programming solution. Step 2. Skips the problem and reads another problem in the problem set. Still, uncompetitive programmer C, slow. Step 1. Reads the problem and realizes that it is a hard problem. Minimum weight perfect matching on a small general weighted graph. However, since the input size is small, this problem is solvable using DP. The DP state is a bitmask that describes a matching status, and matching unmatched students I and j will turn on 2 bits I and j in the bitmask. Step 2. Codes I/O routine, writes recursive top-down DP, tests, debugs greater than, less than. Step 3. After 3 hours, his solution obtains AC, passed all the secret test data. Competitive programmer D completes all the steps taken by uncompetitive programmer C in as less than or equal to 30 minutes. Very competitive programmer E. A very competitive programmer would solve this well-known problem as less than or equal to 15 minutes. Please note that being well-versed in competitive programming is not the end goal, but only a means to an end. The true end goal is to produce all-rounder computer scientists, programmers who are much readier to produce better software and to face harder computer science research problems in the future. The founders of the ACM International Collegiate Programming Contest, ICPC, have this vision. We at the Vector Academy School of Computing play our little role in preparing the current and the future generations to be more competitive in dealing with well-known computer science problems frequently posed in the recent ICPCs and the International Olympiad in Informatics.
Thanks for your time. Share it in your circle to help people search less and learn more. Stay tuned to the Vector Academy.